Hello, and welcome to the fourth video in the 7 Bridges onboarding lesson video series for CAVATICA. This video, Project Fundamentals, will instruct you on some of the basic functionality of the platform and explain the basic organizational unit, the project. The learning objectives for this video are to understand how projects are used as the main organizational unit of research on CAVATICA, that projects are themselves subdivided into dashboard or overview, files, apps, tasks, and interactive data studios. And finally, that collaboration and data security features are readily accessible. At the end of this video, you should be able to add files to a project, add and run a tool within a project, add collaborators to your project and adjust permission settings, and inspect the results of your run tasks. We'll now begin a demonstration where we will create and modify a project. This should be a refresher from the last video. We will upload files and perform a function using a public tool, and we will also modify project access. After logging in to the CAVATICA platform, you'll be taken to the landing page. This platform dashboard is organized into discrete units for projects and analysis. If you remember from last video, we are going to create a new project by clicking one of the Create Project buttons. We're going to name this, making sure we're satisfied with our URL, set the appropriate billing groups and location, toggle spot instances, memoization, and network access to your project needs, and then hit Create. In this new project, we will explore the different sections and their associated functionalities. This dashboard for the project shows you the different sections of your project at a glance. The first section I'd like to point out is your project description, which you can use as a lab notebook. This is helpful for both yourself in the future and if you are collaborating remotely with other scientists. You can finish an analysis and leave notes for the next person who may perform the next part of the analysis, or whatever working structure you need. You can also edit this using Markdown. I would take some time to learn the ins and outs of Markdown on your own. It's rather simple, but there are some very comprehensive guides and quick reference sheets. The next section, again, is members, where you can invite new members to your project and toggle permissions based on levels of necessity, whether or not they need to be able to control the project in total or everything down to just being able to only view results. The next section that I'd like to discuss is the Files section. This section of the project is accessed through the Files tab, and this is what contains files you have uploaded yourself or the symbolic links to those files if they are hosted somewhere else on the platform or somewhere in the cloud, like a volume or a storage bucket. When adding files, there are several ways. You can access datasets, hosted public files, different projects, your computer, file upload services such as FTP or HTTP, data repository services, different data tools, linked volumes, or you can even import from a manifest file. Today, we'll show you how to upload files to from your local computer. Click on My Computer, and you can either browse files as you would uploading to many other sites, or simply just drag and drop. I'm going to upload two files called example data, one with and one without a space. This is dummy data that we're only using for the purposes of this demonstration. You can set some upload settings and then start your upload. These files are small, so it happens fairly quickly. You'll be notified when the upload is complete. And when you are done adding files, exit out of the file upload pop-up. To see our files, if we refresh this page, they should be right here. When we refresh our page, our files will be placed into our overall directory. You can create subdirectories by creating new folders and you can then move data between. The next section of your project we are going to explore is the Apps tab. Our platform brings the analysis to the data by creating instances with the tools necessary to perform analyses in the same space where the data is stored. This prevents any data egress costs. Apps are the instances that you bring to the data to perform the analyses. To use them, you will need to copy them into your project and run them as a task. There are no apps here. If we have several apps, we can search through them. We can toggle different search criteria up here. We can create an app, which we will cover in a later series of videos, or we can add available apps, either from different projects, including ones you've created, or the public apps gallery. There are several hundred different publicly available apps. These apps are all version controlled with return to any previously hosted version at any time. And they are available, stable, and well documented with constant curation by 7bridges and community members. We are always looking to expand our apps gallery with any useful apps that you think we might need or that you would want to develop yourself and distribute. To find an app, we're going to look for a compressor. For the purposes of this video, we chose the compressor because it works with any file type. We have several options. When we click on it, we can get some information, documentation, version control, common uses and important notes, and performance benchmarking for cost approximation. I'm satisfied that this is the app I'm looking for, so I'll want to copy this to my project. Where it should appear in my project's apps page. And there it is. Now that this tool is in our project, we will initialize a run. This is what is present under the tasks section. When you hit run, all of the inputs, outputs, and things that can be edited by default from this version of the app you copied will be accessible for you to change. The task is named after the time and day that it was created, with the ability to edit this. Changing the name can help you organize things in the future to find specific task runs that might have specific results you're looking for. This compressor takes a file, compresses it, and then delivers the compressed file. It requires input files. We will use this example data.csv and save our selection. Oh no, we've been given a warning. This warning was triggered because the name of our file is incompatible with this app. The name of the file must not contain spaces. Since this is the case, we will change our selection, unclick this data in the improper format, and collect this example data to use in our run. We hit Save Selection. Then we move on to App Settings. You can see that this is required. We need to choose what format we would like to put our compressed folder in. tar file is fine. We can also set things like output name. This is optional, however, and the task will run whether or not this field is filled in. When you hit run, the app will begin to perform its task. Right now, it's queued. It should move on to starting, initializing, working, and then finished. To look at all of your tasks in the project, hit tasks, and you can see the live status. This one right now is running. While this task is running, I will show you how to create a Data Studio instance.
Data Studio is a cloud version of Jupyter Notebook or RStudio that executes the same way as it would locally, just on the cloud environment.
Whereas a script might be contained in a tool, it is a script that does a thing. You can actually modify that script and get things ready for batch analysis or any sort of scaled analysis or further pointed inspection of your data. So if we want to create a new analysis, we have to decide first, again, what the analysis name is. We are going to pick the environment we're most comfortable in. We're going to do RStudio. The environment setup here, you might notice, has changed. You can change it to the different hosted versions and different loaded environments for this Data Studio. You can also change the different instance types. It gives you an estimate about how much it will cost, how much storage to include, and suspend time. Running these virtual environments takes a lot of compute power, and it is not advisable to leave these running. The 30-minute timer, which you can change to lengthen, shorten, or turn off altogether, is a safeguard against keeping these interactive data studios up and costing more money than is useful. When we hit start, we create this environment and it begins to initialize. As this initializes, it should go fairly fast through the first two steps. Allocating instance is sending requests to the web servers to allocate the hardware resources. Preparing instance is setting that up and getting it hosted in a space where you can access it through the platform. And finally, when it moves on to preparing analysis environment, that is when the Data Studio is being opened. If you encounter a situation where you get a spinning progress bar on the first or second of this progress chart, it is advisable to go up here and hit stop on the analysis and then try again. This rarely happens, but in those moments where there is high traffic on the site, these requests can be delayed and it is faster to stop and restart. Now that our Data Studio is open, you can see this is a fairly standard RStudio environment where you can add different things like R scripts, and run them in this interactive environment. Anything you can do in R, RStudio, Python, you can do here in these interactive notebooks. We will cover these a little more in depth later, such as how to change directories, designate different output folders, etc. We will also delve into how to turn scripts developed in these different data studios into automatic tools and workflows for scaling up and different batch tasks. When you are done with your data studio, please remember to hit stop. When we hit stop, we'll be navigated back to the data studio page for this specific data studio. If we go back to the data studio page, it will show us all of our different analyses and the status of each. This one is saving, so we know we remembered to close it. Let's take a look at our tasks and see if the compressor has finished its run. It has. The status is green and completed. The duration of time that it took, the price. We can automatically rerun this if we want to rerun a task. That brings us into the same setup window. This should look familiar to you. And then you can edit this for however you need to rerun the task. This one worked, but in an instance where a task might have failed and you realize it was a parameter setting, you can go back after you've set the task up, change things to comply, and run again. This is where memoization comes in, because those intermediate files you might have produced in a failed task, the task will pick up immediately from that step, so it does not waste time or money recomputing those available values. If I decide that I don't want to rerun this task, I'll hit discard. If I need help figuring out what's going on with my task and why it won't work, I can click Get Support here. And again, as a reminder, bottom of every page has this contextual help button link with portal directly to our support. I'll go ahead and discard this task now. You can also change the settings of your project to retroactively change everything except the URL. Project lockdown is for emergency or overly cautious situations and where the project needs to not be exposed even to CAVATICA staff. We will caution you that this limits our ability to help you should any troubleshooting arise. Finally, this project settings window is where the only option to delete the project is present, which you may click and then ask to reconfirm your decision. Looking back at my projects list, in both spaces, you can see that this project has been deleted. To review, we create a project. Within that project, we uploaded files, added an app, ran that app, and then created an interactive data studio. We did ours with R, but you can do yours with Jupyter Notebook and Python as well. The key takeaways for this video are that you understand that projects are the main organizational unit of research on CAVATICA. It's where you store your files, where you store and develop the apps you would like to use, where those apps are run, and where you might do different interactive analyses on our platform. These projects are organized into subcategories: the dashboard or overview, files, apps, tasks, and interactive data studio. Collaboration and data security features are also readily accessible from the description page to block network access and lock down the project, or adding and removing members and their permissions.
This concludes the 4th video on project fundamentals. The next video in the series is adding data to a project. We'll see you there.